To briefly review 10.5's material, if the vertex of an angle is the center of the circle, then the measure of the angle is equal to the measure of the arc that is formed. If the vertex of the angle is inside the circle but not the center, then the measure of the angle is equal to the sum of the two arcs divided by 2. If the vertex of the angle is on the circle, or it's an inscribed angle, then the measure of the angle is equal to the arc divided by 2. If the vertex of the angle is outside of the circle, then the measure of the angle is the difference of the two arcs divided by 2. In 10.6, there are 3 objectives. The first theorem tells us if 2 inscribed or tangent chord angles intercept the same arc, then they are congruent. We're not going to prove it as in write out a proof, but let's think about this for a minute. Let's say the measure of this inscribed angle is A. Then the measure of this arc would be 2A. And then this arc is also formed by Y, and the inscribed angle is half the arc, so it would also be A. Therefore, those 2 angles are congruent. Let's look at an example. Angle C here is 2x plus 3. The measure of the arc is 5x minus 7. So if we take twice the measure of angle C, that will be equal to the measure of the arc. So 4x plus 6 equals 5x minus 7. So x equals 13. So the measure of angle C is 2 times 13 plus 3. That's 36 plus 3, or 39. And we know that angle C has to be congruent to angle D because they form the same arc in the same circle. So the answer is 39 degrees. Our next theorem states if 2 inscribed or tangent chord angles intercept congruent arcs, then they are congruent. Simply stated again, if angle P is A, then arc AB is 2A. We know that these 2 arcs are congruent because they're marked as such. So if CD is 2A, then the measure of angle D has to be A as well. So angle P and angle D are congruent. If we use the diagram above, we're given that arc AB is 50 degrees. That means that the measure of the inscribed angle APB is 25 degrees. And since these arcs are congruent, the angles that form them are also congruent, so CDE is also 25 degrees. An angle inscribed in a semicircle is a right angle. This is actually a carpenter's trick because then we could take a second right angle. Let's see if I can draw it correctly. And if I did, then the intersection of the 2 diameters would in fact be the center of the circle. So we know that an inscribed angle is half the measure of the arc. If it cuts off a half of a circle, then this has to be a right angle. In circle O, BC is a diameter, and the radius is 20.5. That means the diameter has to be 41. AC has a length of 40. Find AB. Well, we know this is a right angle because it forms a diameter, and that is the optional Pythagorean triple that you could have memorized, 9, 40, 41. If you weren't sure, then you could have gone ahead and said AB squared plus 40 squared equals 41 squared and solved for AB. The sum of the measures of the tangent-tangent angle, P, and its minor arc, ST, are 180. So let's look at an example from yesterday's assignment. Yesterday, we took the long way, and I was hoping that someone would mention it to me, but no one did. This is 360 degrees all the way around the circle, so the major arc is 360 minus 106. Then you would have to subtract those two, divide by 2 to get the measure of the angle. Well, with this theorem, we can simply say that the measure of angle W is 74 degrees.